This is number 2, where we have a force 40 newtons that accelerates it, and the acceleration is 6 meters per second, and there's a frictional force. So we need to find is how big is the frictional force and the coefficient of friction. So we have 40 newtons that makes it move, applied force, and we have frictional force that we don't know. So the givens are that we have force applied of 40 newtons. We have a mass of 5 kilograms, which from that we can find force of earth on the object, which is down, and then force normal, which is up. Force of earth is 5 times 9.81 meters per second squared, which is 49 newtons. How large is the frictional force? What we need to do is, we also know the acceleration to be 6 meters per second. And then knowing the acceleration, and the mass, we can find the net force. And F net is 5 times 6 meters per second. It's 5 times 6, which is 30 newtons. So that's a net force. So the combination of this force and this force together gives us 30 newtons. So F net equals add all forces, which is 30 newtons, which equals force applied plus force of friction, so 30 newtons equals force applied, which was 40 newtons, plus force of friction, subtract 40, force of friction equals negative 10 newtons. That's part A. Part B, we can define the coefficient of friction. And the coefficient of friction, in this case kinetic, equals force times force normal, which we already know that's the same thing as force of earth. So the frictional force is, we just calculated to be negative 10, equals the coefficient times force normal, which is force of earth, which is 30 newtons. So coefficient of friction is 10 divided by 30. It's negative, but we can drop that. So that's 0.333. No units, because this is in newtons and this is in newtons. So the answer is unitless, and we can drop the negative because it's not a vector.